So in this video, I'm on page 5, and I'm going to be reviewing how to simplify things with exponents, with fractions, and with radicals. And so we're basically just going to work down each column here. First, I'm going to start out with the exponents. And I want to remind you guys here for number 1 that in parentheses, we have a -3, which makes it the base. That's B-A-S-E. And we're going to square it, which means we've got a -3 times a -3. So a negative times a negative is going to be a +9. Now for number 2, we have a 4. We're going to multiply it by itself 3 times. So we've got 4 times 4 is 16, and then 16 times 4 would be 64. All right. What a lot of people do here is sometimes 4 times 3, but first we've got our 16, and then times 4, 64. All right, and number 3, in parentheses, we have a -2, so our base is a negative times a negative times a negative. Now, y'all, these first two, negative times negative, that's a +4. And now you've got 4 times -2, so that's why it's back to a -8. Now, we have learned this stuff, so be careful here for number 4. We've got 7 times 7, and that's going to be 49, and then the negative, because it's not in parentheses, means we have a -49. And the whole point is, like, now in PEMDAS, you're going to see things like, now let's have a 50 out in front, so 50 minus 7 squared. And basically what you're doing is 50 minus the 49, which would of course go on to be a 1. But the point is that without that for right now, that would be the -49. And here again, it'd be like saying we're going to subtract 3 squared. So what we'd be doing would be subtracting 9. All right. Now I've got some visuals here to help with the fractions. I really like these visuals. And so what we're going to do here is we're going to take this number and we're going to break it up into the denominator that it says to break it up into. And then we're going to take the number of sections right here. So if we take 12, y'all, and break it up into 3 parts, that's right here. That's going to be a 4, a 4, and a 4. Now what we're going to do is take 2 of these sections. And so 4 plus 4, that's going to be 8. So 2 of our thirds would be 8. Now I do want to point out that in elementary school, they would have told you to multiply the numerator times the numerator, and then the denominator times the denominator and simplify. So here we get a 24, and with the denominator we'd get a 3, and 24 divided by 3 is 8. So if you prefer to do 12 times 2 and get 24 and then divide it by 3, you can get the same answer. What my visual shows is 12 divided by 3. That means each section is worth 4. Now I want times 2, so that'd be 8. So with my visual here, if I take 20, if this bar is meant to represent 20 and I break it up into fourths, 20 divided by 4 is 5, and so just one of these sections then is worth 5. Again, you have the option to do 20 times 1, which is 20, divided by 4, 5. All right, now for number 3 here, we're going to take 48 and break it up into fourths. 48 divided by 4 is 12, and now we want 3 of those sections, so that's going to be a 36. And you can see here why you might not want to do the 48 times 3, because then that's going to be a big number, and then trying to divide by 4. Now you could use a calculator and do 48 times 3 and then divide it by 4, but the point is just quicker with mental math. Take the 48 and break it down into fourths, and now just multiply by the 3. All right, so if we have 18 and we just take a third of that, we're just basically dividing by 3. So 18 divided by 3 is going to be 6. And there's a visual here. 18 broken up into 3 parts. Each one's worth 6. And then we just want one of the sections. So that'd be a 6. And here for number 5, we've got 10 divided by 5. That's going to be 2. Each section would be worth 2. And now 2 of those, so 10 divided by 5 is 2, times 2 would be 4. All right, and now in our last column, we've got practice with radicals, and so that's going to be the fancy word for that square root sign. And so, for example, for number 1, 81 is a perfect square, and we just want to know what number times itself would give you 81, so it's going to be 9. And friendly reminder to check, if you just do 9 times 9, you will get 81, so that's how you know you're right. Now for number 2 here, what I'm going to point out is that the radical kind of acts as a grouping symbol, where first you want to simplify the radicand, and I'm going to type that word into here right now, radicand. In this situation, the radicand is the 16 plus 9. So I'll highlight that so that it kind of is color-coded for you to see it. This is the radicand. In number 1, the radicand was already just an 81. So when we simplify, we get 16 plus 9, and now the radicand is a 25. And so now we can take the square root of that, and the answer would be 5. So here when we simplify the radicand, 16 plus 9 is still a 25. And when we take the square root of that, we get a 5. And then the negative out front, the answer would be a negative 5. All right, so now for number 4, when we simplify the radicand, we've got some multiplication to deal with. So we've got 2 times 9, which is 18. And then we've got 6 times 3, which is 18. And we're going to add those two together. So 18 plus 18 is a 36. So now when we take the square root of 36, we're going to get 6. And right here, now you can kind of see this first column in action where we're going to be taking away 9 squared, so we're going to be taking away 81. And if that was a problem over here, the negative 9 squared would be the answer of negative 81 because the negative 9 is not in parentheses. So now when we have 225 minus 81, our radicand is 144, and the square root of 144 is 12. And that concludes this video on page 5. Thank you.